It's me. It's me.
Betapa ku mencinta.
The data that we use is the number of registered divorces in Malaysia from 2018 to 2024, highlighting the annual trend and overall changes in divorces cases over a 7-year period. The statistics cover all state and federal territories in Malaysia. The information is collected and published by the Department of Statistics Malaysia (DOSM) using official divorce record from the National Registration Department (JPN) and relevant religious authorities. The purpose of collecting this data is to monitor changes in divorce trend over time. It also supports government planning and policy development related to family welfare. In addition, it provides important demographic information for researchers, policymakers and the public to understand changes in family structure and social condition in Malaysia. All data is based on officially registered cases which are verified and compiled by the DOSM before publication. This is the graph that we obtained from the DOSM official website. This is our table that we changed the year into the code year to make calculate easier. Thus, this data can be used to study trends and make prediction. Therefore, 3 models were tested: the linear model, quadratic model and cubic model.
Best fit linear curve, the equation is y equal to a plus bx, y number of divorce, x year, which coded as 1 to 7, 1 equal to 2018. A, B is the coefficient that need to determine. Next, form of matrix and M equal to AB, which is matrix A and B from the previous slide. Then, use RREF. As you can see at the highlighted part, 0 is not equal to 1, so the system is inconsistent. Use normal system to determine the type of solution. As you can see in the slide, the determinant of A transpose A, we got 196, which is not equal to 0, so the normal system has unique solution. Next, use least square solution to solve A transpose X equal to A transpose B, and using the augmented matrix and RREF to get the coefficient of A and B. Lastly, finding the least square error vector and graph. For the equation for error vector is B minus AX, then the answer we got is 15046.96722, and the graph we use equation YT equal to 332791 over 7 plus 47793 over 28T.
The calculation for this quadratic model is the same as linear model before, so I will just quickly explain the equation, graph and error. First, let's look at number 1. This is the quadratic model. We use the formula y equal to a plus bx plus cs squared. From our data, we got the equation shown here where t represents the year. Next, let's look at number 2. This graph shows the quadratic model. The blue dots are the actual data and the purple line is the quadratic trend. You can see the line goes down a little at the beginning, then it starts to increase. The highest point is at the end of the graph, while the lowest point is around the middle. Finally, look at number 3. We calculate the error to see how good the model is. The total error for this quadratic model is 14,064.26. The calculation for this cubic model is the same as previous model, so I will just quickly explain the equation, graph and error. First, let's look at number 1. This is the cubic model. We use the formula y equal to a plus bx plus cx squared plus dx cubic. From our data, we got the equation shown here where t represents the year. Next, let's look at number 2. This graph shows the cubic model. The blue dots are the actual data and the purple line is the cubic trend. You can see the line goes down at the beginning and then it goes up quickly. Finally, let's look at number 3. We calculate the error to see how good the model is. The total error for this cubic model is 13,685.42. The lower the error, the better the model fits the data.
Among the three models, linear, quadratic and cubic, the cubic curve gives the best fit for the data. This is because it has the smallest magnitude of error, which is 13,685.42376. A smaller error means the predicted values are closer to the actual divorce statistics. Therefore, the cubic polynomial is the best model to represent the given data. By using the cubic polynomial, the predicted number of registered divorces is shown below. Based on the cubic polynomial, the number of registered divorces is predicted to decrease over the next 3 years. The predicted values are 60,258 in 2025, 55,304 in 2026, and 44,899 in 2037 with the year code 8, 9 and 10 respectively. This shows a downward trend in the number of divorce cases. Since the cubic polynomial has the smallest error, it gives the best prediction for the given data.
Que hoje a resenha na laje. Fica até tarde pra caprichar na marquinha. Toma